Hello everyone and welcome back to my channel. Today we will be talking about parallelograms. Now the word may sound big, but don't worry. In this video, I'll make everything seem very easy to learn about parallelograms. So if you watched my previous video, we talked about different types of polygons. So parallelograms fall under that same category of polygons because they have sides, and they're not like a circle, which don't contain any sides. And to be more specific, a parallelogram is a convex polygon. Okay, so before we start learning about parallelograms, we have to learn about this big umbrella category that the parallelograms fall under. These are called quadrilaterals. So, what is a quadrilateral? So, a quadrilateral is any polygon that has four sides. So it's any polygon that has four sides. So a quadrilateral can be a square, rectangle. Oh, that's not a rectangle. A rectangle. Okay, that is not a good rectangle. It could be a rectangle, or it could be a trapezoid. And in our case today, it could be a parallelogram. Okay, so that now that we have covered about quadrilaterals and the big subcategory that parallelograms fall under, we'll start talking about parallelograms. So let's find out the definition. So for short form, I'm just going to call parallelograms para because yes, it does have a very long name. So I'm just going to call it para. So a parallelogram is a quadrilateral, and I'm going to call it quadrilateral quad. A quadrilateral with two pairs, two pairs of parallel sides. Sides. Hence the name parallelogram. So a parallelogram kind of looks like this. So it has a parallel side right here and a parallel side right here. So that's what a parallelogram is. Okay, so a parallelogram has some properties that come with it. Just like how polygons had theorems, parallelograms come with properties. So property of parallelogram number one. So the property of a parallelogram number one. So what this property states is that if a quadrilateral is a parallelogram, then the opposite sides are congruent. So let me write that down. So if an object is a parallelogram, I'm just going to draw a parallelogram like this, and I'll just write para inside of it. Para. An object, if a quadrilateral is a parallelogram, then opposite sides are congruent. So opposite sides are congruent. So this is the symbol for congruency. So opposite sides are congruent. So for example, we'll have a parallelogram drawn right here. That's the parallelogram, I guess. And then always a parallelogram has parallel sides, two pairs. So what this is stating is that um, this side is also congruent to this side. This side is congruent to this side, and this side is congruent to this side. So that's what this theorem is saying. It basically says that opposite sides are congruent in a parallelogram. Now remember, these theorems only work for a parallelogram. Okay, so let me just draw a neater model right here. So we'll have a parallelogram right here. So now in a parallelogram, we know that this side, I'll draw it in a different color. this side will always be parallel to this side, and this side will always be parallel to this side. Now, what this theorem is saying is that this side will also be congruent to this side, and this side will always be congruent to this side. So let's give these some names. So A, B, C, D. So what this is basically saying is that AB would be congruent to CD, and BD would be congruent to AC. That's what this theorem says. Okay, let's move on to property of parallelograms number 2. So prop of para number 2. Okay, oh, whoops. Property of parallelogram number 2. So what this property states is that if a figure is a parallelogram, then opposite angles are congruent. So it's very, very similar to the previous one. So if an object is a parallelogram, uh, that's not a parallelogram. So I'll just write para. Object is a para, then opposite angles are congruent. So if we were to draw a model of this, it would look very similar to the first one, except we would not have the sides congruent, we would have the angles congruent. So let me just draw that real quick. Okay. Parallel sides. Yeah. So what this would be saying is that this would be congruent to this, and this would be congruent to this. Now note, this angle will not be congruent to this angle. These are not opposite. These are corresponding or alternate. These these would be opposite. This one and this one. So basically, it's the angles that lie on the diagonals of the parallelogram. This would be a diagonal. So this angle lies on the diagonal and this angle. So since those two angles lie on the diagonal, same diagonal, they would be congruent. So that's the property of parallelograms number 2. Now we're going to talk about property of parallelograms number 3. So if I can just delete all this. Okay. So property of parallelogram 3. Prop of para number 3. Okay. So parallelograms have always had the same common properties. So this one is one. So the previous two have always had like similarities, but this is the first one that is completely different from the others. So what this says is that if an object is a parallelogram, then the diagonals bisect each other. So diagonals. I'm just gonna write diags bisect each other. Each other. So that's how you spell it. Other. So what this basically means is that so if we were to find out what this bisect mean if we have like this side would be congruent to this side, and this side would be congruent to this side. It just means it cuts whatever it's intersecting. The two lines cut themselves in half. So if we were to draw that with the parallelogram, we can see that this diagonal right here, this diagonal would bisect this diagonal. So this would be. I know they don't look that like they bisect each other. Yeah, it's just my drawing is really bad. So that's basically what it means. That the diagonals bisect each other. So that was basically it for today's video. It was just a quick summary about parallelograms and the definition and the properties related to parallelograms. Thank you so much for watching, and don't forget to like and subscribe. See you next time.